All right, so today's goal is to make a wheel that can go on a stepper motor like this. Now this shaft right here, it has a name. So it's like a perfectly round shaft and they shave like a flat area on it. It's called a D shaft because if you look from the front, it's sort of like the letter D. It's round and then it has a flat side. So that's called the D shaft stepper motor. Or a D shaft right here. The stepper motor is something different. And this particular motor we use is a NEMA17. Um, 17 is because it's kind of weird, but it's 1.7 inches wide. This whole motor, not the screws. The entire motor is 1.7 inches. So I don't know. They moved the decimal place and they call it a NEMA 17. So it's 1.7 inches by 1.7 inches, and you can measure that. It should be about that. So that's what this NEMA 17 is. And they have NEMA 23s and all kinds of stuff, which is a 2.3 inch stepper motor. So we need to create something with a flat edge like this. See how it's kind of D-shaped, and it's going to fit in here. And of course, I'm removing these because that's a waste of plastic. And plastic kind of looks cooler than just a big smooth side. But you could try a different pattern than what I have. Whatever you want to do, if you want to make it look cooler than that. All right, so how do we get that started? So let's go here, and then we're going to go to Create Document, and we'll call this the uh, D shaft stepper wheel or something like that, whatever you want to call it. And we'll call it that. And the first thing we're going to do is make the entire full wheel, the full circle. So let's sketch. And we'll just choose to do it here on the bottom, rotate it towards us. And I found that a 2 inches is like the bare minimum size. You can make it bigger, but you can't really make it any smaller because remember, this is a NEMA 17, so it's 1.7 inches wide. If this wheel is not bigger than the motor, then it's not going to touch the floor. So I found that like this 2 inches is pretty much the bare minimum uh, to work. Okay, and like I said, you can make it bigger if you like. That might change your other numbers though. So I'm going to make it 2 inches. And of course, let me just rotate it so you can see that I'm going to extrude it. And this isn't super important. You could do a 1/2 inch. I don't know why I just chose 55 inch, 0.55 inches. I think I was designing it for rubber band or something like that, but in the end, I'm not using one as of right now. And then once we do that, I want to create the pattern around the sides, that where I cut out stuff. So I'm going to sketch this right here, sketching this front plane. And this is the first time I ever did something like this design. So it took me a minute, but what I did is I did a little circle here and I made it this size. And this is very important, this size. Oops. What happened here? There we go, 0.75. I chose 0.75. Actually, that's not right. I did not use 0.75 because it doesn't look that big, did it? Oh, I guess it doesn't really matter, but I do need enough room here to work around and make my hole and stuff like that, in other words. So I do need to leave some extra material. But then I created a larger one. Now this one is important because however big I make this one, is how much material is left here. Because you need something there for the wheel to have some material. So I think I did this at 1.9, which left a really thin, plastic all the way around the outside. Now I need a section right here that I can cut out. So what I did is I took 2 lines and I started from the hub here and I clicked on this wall. So this outer circle, I clicked on it. And then it's still stuck, so push escape on your key. That'll make you get out of that tool. Then click this so you can start a new line. Click that dot in the center and click the wall again. Now I'm stuck in the tool again, so push escape key and that'll get you out. And then dimension. So I want this circle, and you could do a different width. I want it to be 70 degrees. Because remember, from this line to this line is 90. So I can't remove 90 because if I remove 90 and I pattern it, I'm removing everything. So I can't do that. And so I'm doing 70 and I need this line to be half of the remainder. So 70 degrees out of the 90, that would leave 20 left. So I'm going to do 10. And that way there's 10 here, 10 degrees, and there's 10 degrees here. And I'm going to remove this chunk right here. So from here to here to here to here, this piece. And we could delete a bunch of stuff if you wanted to. I don't think we have to. I'll come back if I have to, but I think I could just say done. And by the way, you do notice that all my lines are black. That means it's fully construed. There's nothing else I can actually write without getting an error. Now I'm going to go to extrude, and I want to extrude this section. See how it lets me click this one or this one, whatever piece I want, this big section. I want this one. And I'm going to say remove it. And yeah, it's removed all the way through. Perfect. So there we go. I got my section gone. Now I just need to say pattern tool right here. This is linear pattern. Click the little arrow to go to circular pattern. And then it's asking, what do you want to pattern? By the way, we don't want to pattern a whole part. We just want to pattern a feature of our part. In fact, this feature right here. If you can't click on it like this, just click the extrude button right here. That should be able to do it. So it's saying, oh, you want to take that extrusion and pattern it. So I just clicked that extrusion because it didn't allow me to click this for some reason. Then it wants to know the axis of pattern. So click that. And I'm going to say that roundness right there. And it automatically chose 4 for me. And I want to do it all the way 360 degrees. And I want 4 of them. 1, 2, 3, 4. So that seemed to work for me. And there you go. Now you could choose a different route. You could do a different angle and do, 6 of them, 8 of them, whatever you want to do. Um, Remember, the more little intricate holes you put, though, the more chances the printer will have to error. Mine just has to cover this one hole. If you have tons of holes, that's a lot of points of error. All right, so now let's worry about the shaft right here in the middle. So let's sketch and let's click here. And let's make that D shaft slot. So um, let's start in the center. And how wide is this thing? Well, I looked up, and I have it here somewhere. I looked up a dimension sheet for NEMA17 motors, and I came up with this, and you can see it's 42.3 maximum millimeters wide. So if we convert 42.3, you get almost the 1.7, rounded to 1.7. So that's what I said. It was NEMA17 is 1.7 inches. So let's go back here. So I found out that right here, it does tell me about this. Now you can use dial calipers for this, but I found that the full shaft width is right here, 5 millimeters. But the cut part right here where it's flatter is 4.5, okay? But remember, we need some tolerances. If I put exactly that, it's going to be so tight and hard to fit in there. And maybe not fit at all, depending on the 3D printer errors. So I found with a little bit of experimentation, it took me about 3 or 4 tries of printing and getting it to work. I found that if I use 5.4 millimeters, and you could change it to millimeters, because remember, right now, let me push finish real quick. We are working in, where is that thing? Right here, these 3 dots. So these 3 lines right here, we go to workspace units. I'm working in inches right now, see? So I can still choose certain things to be in millimeters, and that's fine. So let me double click on my sketch to finish this up. So there's my circle. Now, I need a slot. Now, I could just put a slot like this, and choose how far away it is and stuff, but I will not do that. I want the line to be this way, like this. That's because I'm going to put a set screw on the side that can tighten the shaft so the wheel won't fall off. And I only have space here. I don't have space here. There's a big old plastic thing here. So I need it here. And you can tell since I have 4 of these that that's a 45-degree angle. So also, I guess keep in mind when you make these big holes as your pattern, you need a space to put the spacer, okay? Or sorry, the insert where we're going to put the screw. So let's go here to the dimension tool. And I notice from this line to this line, there we go. I want that to be 45 degrees. That should line it up perfectly. Then, if you remember this one right here, this is 4.5, and then 5 is a mount, so about a half a millimeter in. So, 5 minus 4.5, so that leaves us a half a millimeter. So let's go back here and let's do that. Let me zoom in so you can see this a little bit better. And I'm in the dimensioning tool, and I'm going to say from this line to the outer edge is 5, no, not 5, 0.5 millimeters. There we go. And so that should do it. And I'm fully constrained, which means all the lines are black. And then we can go to extrude, and I say I want that extruded, but I want to remove it. Now, I don't want to remove all the way through. I guess you technically could, but I just thought it would look cooler if I didn't. So I'm going to, leave a little bit in there, you know. I don't know how much. Well, let's figure it out. I have remember the whole thickness of my wheel is 0.55 at the beginning. So if I do 0.5, that'll leave, you know, 0.05 thickness wall, so that you don't see the outside. So the outside of the car, you don't see the hub, or the inside of the hub anyway. So that's pretty much it. This will work already, but the wheel could totally fall off, right? Unless you put glue or something, and that's just not good practice, putting glue. So let's put a hole right here. So we're going to need to put a plane there. So I'm going to remove these planes. You can see these planes, this plane right here. I want to move these things. So just, you don't have to remove them, just hide them by clicking the eye so we're not looking at them. And let's see if we could create a new plane right here. There we go. So I just created a new plane there. Oh, it gave me an error. Line angle. Oh yeah, so let's see, 90 degrees. Let's see if this gives me, no, this gave me an error. So I think I'm gonna have to create a brand new one out of an old one. So let's do that one. So I have these old ones here, are the ones we use all the time. So let's see here. And which one lines up? There we go, that one. So let's unhide that one. You see how it's flat, perfectly in line with this. I'm gonna create plane. Oh, no. Well, let's see if that works. 45. That also doesn't work. Sometimes this is experimenting if you don't do this a lot. Offset surface, plane. Oh, here we go. Maybe this is it. Line angle, plane point offset. So I'm going to say plane angle, line angle, and I'm going to say this one, and I'm going to say flip it 45 degrees. Flip normal. Line angle, no. Okay, see, it lets me offset it, but I don't want to offset it. I want to create a new one that's a line angle. Let me pause this and I will explain this in a second. Okay, so I got it figured out. There's two ways to do it. Um, the first way is you can click plane and then we'll go to offset. But I actually want the plane here. So I could just add offset it by a very, very small amount, and make sure it's kind of not into the part. So if you look at the arrow, where's the arrow at? There it is, the arrow. It's going this way, only like a tiny amount. So there's the plane there. You can kind of see it. Let's see. See plane one. And I'll delete it. And the other way is more complex. It was that other way. Click plane. And then we did that line angle. And I can click this line and then do the 90 degrees. And I think that's how I did it before. And see, it still gives me a flat plane right there. And that's what I really want. It's because I want to draw right here on this surface, but I can't see it when I do this, so I need to slice this thing. So just right click anywhere and go to section view, and then it just takes a chunk away. I don't know, it just chooses kind of randomly, so just exit out of that, and it says what section do you want to view? I want to view from that plane. If it's hard to click on, just click here. That's that plane. When we click there, it'll slice down to that. And you can push green check mark, see? And now I can see right here where I'm going to put this hole. Now we can sketch on, I guess, this plane technically. So we can click that plane. So we're drawing on that plane. And then you can right click and say view normal to sketch plane. There we go. So that means like normal, like straight in front of it. That's what that means. And we need to make a hole that we're going to create for our little brass insert. So if you're looking for that, you go brass insert M3 and then times, I think it's the one I'm using is 5.7. And it's these right here. So it looks like that. There's a bigger version of it right here. And they're really tiny, and they do give you the dimensions. The M3 is the 3mm screw inside, so the outside's around 4mm. So I had to play around with this a little bit, and it turns out with the 3D printer and everything, about 4.2mm is just about right. So just 4.2, and then put in millimeters. And I want that in the middle, so you can just click the middle of your circle and edge, oh, like that point right there. And then we'll just do, the whole wheel is 0.55, and then put divided by 2. Or you can do the math in a calculator and put that, but sometimes it's easier just to do that. You don't even have to calculate anything. And there's the halfway point. It's all black, so that means we're good to go. And we're gonna push go. Okay, so once I'm done with that, I can say extrude. That way you can still see what I'm doing here. And we're gonna say remove. We're not trying to add material. Where is it removing to? You saw it's going the wrong way. The arrow's this way. So we can just click the opposite direction. See this little arrow? And that'll send us the opposite direction. You could go all the way through here because I do need a tool to work here, but the tool probably won't fit. It might, but you can always make a bigger hole and design a bigger hole later if you wanted to. I think I had to do that, but we won't do that for this assignment. So we'll just leave it like that all the way through. And the depth is, I guess it doesn't matter as long as we go all the way through. And we'll say done. And then I think that's it. Now you want to see your whole wheel. So right click somewhere and say turn section view off. And there we go. That is our wheel. And of course, as a reminder, if you really wanted to print this, you can right click on the part. There should only be one part here if you've done it right. And then you say export. And then we would make sure it's an STL file. You make sure you name it binary, millimeters, fine resolution, and export. And you can upload that into a Google form to have it 3D printed in our academy somewhere. And that's about it.